Okay, so today we're talking about imaginary numbers. Imaginary numbers are what we use in order to calculate or work with the square root of negatives. Because we cannot take the square root of a negative number, it's actually impossible. We use the square root of -1 and the variable I to represent these numbers. So if I is equal to the square root of -1, I squared is equal to the square root of -1 times the square root of -1, which is just -1. So these are two important facts. I is equal to the square root of -1. I squared is equal to -1. So a couple things here to simplify. If we have the square root of -4, we simplify this by splitting the square root of -4 into the square root of 1 times 4. Okay, and then we can take that and split it further into the square root of -1 times the square root of 4. So the square root of -1, that's what we change into I. And the square root of 4, we know that's 2, so that's what I put in front of the I, 2. Numbers, every time we take the square root of a perfect square, we get a whole number. That integer we put in front of our variable. So we end up with 2I. Now, if you know all these steps, you can skip this and go straight into 2I or I square root of 4. So for example, this second example, square root of -25, I know that is the same thing as I square root of 25. That's how we get rid of the negative. To get rid of the negative, all we do is put an I on the outside. And then the square root of 25 is going to give us 5. So this is 5I. For the examples below, square root of -72. The square root of -72 is not a perfect square. So I can go ahead and get rid of the negative by putting I on the outside, but I can still simplify this radical. So this is what we did Monday. So I can take the radical 72, or square root of 72. I look for the perfect square that can divide into 72. And if you don't remember the perfect squares, make sure that when you get your test on a scratch sheet of paper, write out your squares. So the perfect squares are 4, 9, 16, 25. If you can't remember these, just do 2 times 2, see what that is. 3 times 3, see what that gives you. 4 times 4, 5 times 5, and so on. Okay, you need this list of perfect squares. These are important. So I go to 72 and I divide 72 by 4. Gives me a decimal. I take 72, I divide it by 9. Take 72, I divide it by 16, and I continue on until I find the largest perfect square that can divide into 72. And it ends up being 36. So when I take 72 divided by 36, I get 2. So that means my two factors are 36 and 2. So the square root of 36 times 2, the square root of 36 is going to give me 6. So on the outside I'll have 6I. And on the inside, the square root of 2, I cannot take that and simplify it any further. So I leave the 2 on the inside of the square root. The 36, square root of 36 gives me 6, so I put that on the outside. So this is my final answer. My second example here, the square root of -18. So I'm going to change that into I square root of 18. So again, taking this number and I'm dividing it by each square, or each perfect square, until I find one that can divide evenly into 18. So if I take 18 divided by 4, I get a decimal. 18 divided by 9, I can divide 18 by 9. So that is probably my highest perfect square. So I can change that into 9 times 2. The square root of 9 is 3, so I can bring that to the outside now. And again, square root of 2, we cannot take the square root of 2, cannot simplify it any further, so that is my answer. Okay, for the next set of problems, we have -2I times -7I. So -2 times -7 is positive 14. And I times I is going to give me I squared. But as we said up above here, I squared is equal to -1. So I replace that with a -1. 14 times -1 gives me -14. For the second example, same thing. -3 times -10 is going to be a positive 30. And then when I multiply I times I get I squared. Oops. But remember, I squared is equal to -1, so I'm going to replace that. So 30 times -1 is equal to -30. And then finally for my last example over here, I am adding these. Anytime I add or subtract, all I do is I add or subtract the two real parts and the two imaginary parts of my complex numbers. So I am going to do 2 plus 6. 2 plus 6 gives me 8. And then negative 3i plus negative 9i. Negative 3 plus negative 9 is going to give me a positive 6i. And that's it. For this second example here, I'm doing subtraction. 3 minus 10. 3 minus 10 is going to give me negative 7. And negative 6i minus negative I. When I do minus a negative, remember minus a negative is going to change that into a plus. Okay, minus a negative is going to change that into a plus. And 6i and I, when I combine those, I get 7i. So this would be my final answer. Alright, so this is imaginary numbers continued. So now we are going to be dividing two complex numbers. So in order to divide two complex numbers, what we really want to do here is multiply by the complex conjugate of the denominator. So the complex conjugate of 7 minus 5i is 7 plus 5i. And in order to make it so that we haven't actually changed the value of what we started with, we're going to be multiplying the top by 7 plus 5i as well. Because when I multiply by a number divided by itself, a number over itself is equal to 1, and anything times 1 is still just that number. Okay? So 7 plus 5i over 7 plus 5i, this is the same thing as 1. So in order to multiply these, I'm going to FOIL. So remember, FOIL stands for first, outer, inner, last. So I start with the first terms in each of my binomials. So I'm going to do 6 times 7. 6 times 7 gives me 42. Next I do my outer terms, so the one that's all the way on the left and the one that's all the way on the right. So 6 times 5i. It's going to be plus 30i. Then I do my inner terms, 3i and 7. So 3 times 7i, or 3i times 7, sorry, is going to be 21i. And then finally I do my my last terms, 3i times 5i. So 3i times 5i is going to give me positive 15i squared. In the denominator I do the same thing, so 7 times 7 will give me 49. 7 times 5i will give me a positive plus 35i. Negative 5i times 7 will give me minus 35i. And then a negative 5i times a positive 5i will give me minus 25i squared. Okay, so continuing to simplify this, on the top we can combine like terms. And then if you guys will remember on the last page, I squared is the same thing as negative 1. So what we're going to do is we're going to rewrite by combining the like terms, so we get 41i. And we're rewriting the I squared, and we're going to make that a negative 1. So in the denominator, we're going to do the same thing. We're going to combine like terms, and when I combine 35i and a negative 35i, they end up canceling out. So I'll end up with 49 minus 25. And remember, I squared is the same thing as negative 1, so I'm going to change that into a negative 1. Okay, so then simplifying further, that's 42 plus 41i. Whoops, 41i. And then 15 times negative 1 is going to change that into a negative 15 or minus 15. And in the denominator, negative 25 times a negative 1 will change that to a plus 25. So then combining like terms for a final time, 42 and negative 15, that's going to combine to give me 27 plus 41i over, and 49 plus 25 is going to give me 74. Okay, so my final step is to take this and split it so that I have a complex number. If you guys remember, a complex number is a plus bi. So I need to take 27 plus 41i over 74. And now I'm just going to take that and split it into 27 over 74 plus plus 41 over 74i. So now I have it split into the real portion of my number and the imaginary. Okay, so this is something we practiced using Kahoot in class. We want to know what is the vertex of y equals x squared minus 2x minus 5. So there is a formula that we have to know for this, negative b over 2a. So we're going to plug in b and a. So first we need to find out what b and a are. So b is negative 2, and a is equal to the number in front of x squared. A is equal to 1. So I'm going to plug these into my formula. I get negative 2 over 2 times 1. So my negatives on the top will cancel out to a positive 2. 2 times 1 will give me positive 2. So my x-coordinate of the vertex is going to end up being 1. In order to find the y-coordinate, I take 1 and I plug it into my equation. So I'm going to take x squared minus 2x minus 5, and I'm plugging in 1 for x. So my y is equal to 1 squared minus 2 times 1 minus 5. And that ends up giving me 1 minus 2 minus 5, which is equal to negative 8. 1 minus 2 is negative 1, minus 5 is 6. Oh, sorry, negative 6. And so my coordinates are 1, comma, negative 6. The next question is to rewrite the equation y equals x squared minus 2x minus 5. We're going to rewrite it put it in vertex form. So vertex form is y equals a parentheses x minus h plus k. So we're going to take it from standard form and put it in vertex form. There are a couple different ways to do that. The easiest way is to figure out what a, h, and k are and plug them in. So a is going to be equivalent to the a in standard form. So in this case, a is 1. So when I plug that in, a is still going to be 1. H and k are the coordinates of our vertex. And we actually already found the coordinates of our vertex. If you guys recall from the last page, our vertex was 1, negative 6. This is the same problem. So 1, negative 6, that's our vertex, our h and our k. So 1 and negative 6 are h and k. And we plug all three of these numbers in. So my equation is a parentheses x minus h plus k. I plug in a is just 1. My h is 1, so x minus 1. And then plus k, and k is negative 6, so I'm going to make that a minus 6. And I don't have to actually write that 1. The 1 is going to be implied if I leave it out. So I don't need to write this 1. I just write x minus 1. Oh, I'm sorry, squared. These should be squared. There we go. Okay, and that's how I put something in vertex form. The last thing that we're going to talk about is what we did in Kahoot, maximum and minimum. So to find whether we have a maximum or minimum, we look at the number in front of the parentheses. So for this first example, we have a positive 2. If you guys remember from class, just think of Max. Max is a very negative guy. If you remember, negative is max, and that looks like a sad face. That's what the parabola looks like. So it has a maximum point, and all the other points are below it. So in this case, it's going to be a positive 2, so it's a minimum. If you guys remember, minimum looks like a happy face. It has a minimum value, and all the other points are above that line, or that point, sorry. So for this one, it is a minimum. So we're going to say it's a minimum. And we have to state where the minimum is. So it's a minimum at, and it's at the y-coordinate of the vertex. And if you guys remember, when we have an equation in vertex form, the y-coordinate of the vertex is the number on the outside of the parentheses. It's your k. So it's a minimum at negative 6. So for the next problem, we have a negative. So remember, max is negative. So this one is going to be a maximum. And it is a maximum at the y-coordinate of the vertex. So again, looking on the outside of the parentheses, maximum at 7. For the next one, if you want, try and pause the video and see if you can do these on your own. Okay, so for the next one, this is a positive number. If there's not a number in front of the parentheses, it means it's a positive 1. So this is a minimum value, and it is a minimum at positive 9. And then finally for the last one, negative 4, that is a negative, so it's going to be a maximum value, and it will be a maximum at negative 10.